In this section, 13.4, we will be discussing many different ways of expressing concentration in chemistry. As you view this PowerPoint, be sure to pause occasionally to record important formulas or other information. Previously, we've been discussing solubility. And when you talk about solubility, often we are concerned in chemistry with how much solute is present in a given solution. Sometimes we apply the terms dilute and concentrated. And a dilute solution would have a relatively small concentration of solute, whereas a concentrated solution has a relatively high concentration of solute. They're good terms to use, but usually chemists want to quantify things more than that. They want to be able to put a number on it so they can compare one solution to the other. So the main focus of this section is the various different types of concentration units that are used in chemistry. Molarity is one we have studied previously. Molarity, or capital M, is defined as the number of moles per liters of solution. As we work through Chapter 13, it will be very important to distinguish between liters of solution and liters of solvent. So be sure, as you are reading problems, if you're going to use the molarity formula, we want to make sure we are talking about total liters of solution. Molarity will change with a change in temperature, because as your temperature changes, the volume will either increase or decrease. And since volume is in liters, then your molarity will be effective as well. A very similar but different concentration unit is molality. Molality is represented with a lowercase m. Just like molarity, it also has moles in the numerator. But one difference is that you're dividing by the kilograms of solvent. And be sure as you write this down, you write down kilograms of solvent, not kilograms of solution. Molality does not vary with temperature. Sometimes we would like to change molarity to molality or vice versa. And in that case, density would be required to make a conversion between molarity, capital M, and molality, lowercase m. We do have one additional concentration unit that also is related to moles, and this is called mole fraction. We saw some of this in Chapter 10 when we worked with gases. Mole fraction is represented by the Greek letter chi, and it is defined as moles of component over total moles. Notice there is no times 100 at the end. A couple things about mole fraction. Because it's moles over moles, there will be no units. It's known as a dimensionless quantity in chemistry. And because it's a fraction, its values should range from 0 to 1. Because it's not mole percent, again, it's mole fraction. There are other units in chemistry as well that do not deal with moles, but instead focus on a ratio of the masses of the components to the total solution. Mass percentage, or sometimes called mass percent for short, is the mass of the component divided by the total mass times 100. Sometimes, however, we have solutions that would have very, very small mass percentages because there's so little solute present. So sometimes we need to use other, more appropriate labels, such as parts per million. Parts per million has the same setup as mass percentage. It's still mass of component over total mass, but instead of multiplying by 100, you multiply by 1,000,000, or 10 to the 6th. So you could think of mass percentage as parts per hundred also, which is really all a percent is. If you're talking about drinking water or analyzing very, very small quantities, sometimes we have to go one step further to parts per billion. And parts per billion, or ppb, again has that same similar starting point, mass of component over total mass times this time a billion, or 10 to the ninth. We will be working with all of these formulas in class. Be sure you have written down the formulas for each of these different ways of determining concentration, as well as any other important notes, and bring them with you to class tomorrow.